A hutch is being pulled along a horizontal surface with an applied force that has an angle of 20 degrees below the horizontal. Now, this one is an angle pull. Why? Because the object is pulled along a horizontal surface, but we're pushing or pulling at an angle to a horizontal. This is not an incline. This object will travel along the horizontal surface. So we got to be careful when we read the caption to make sure we understand that this is an angle pull. So what that means is we now have a force applied Y and a force applied X. And our hypotenuse, of course, is just force applied. Okay, opposing the motion is going to be force of friction. And we do have gravity downwards and force normal. Now, because our applied force is at an angle to the horizontal, normal force, okay, will not equal gravity force. And what I like to do with an angle pull is right away get my normal force. Okay, in this case, it's going to be force gravity plus force applied Y, because we are pulling on this object below the horizontal. Okay, if we were pulling above, we would be subtracting force applied Y. But since we're pushing into the ground with our applied force, that'll raise the force normal. So let's go ahead and solve that. So force normal is going to equal 35 times 9.8 plus 130 sine of 20. Okay, I'll write this up here for clarity then. Force normal, okay, does have a value of 387 newtons. Now once again, let's write our force net equation. Force net is going to equal force applied in the x direction minus force of friction. So notice it's this force applied in the x direction, which is really going in this direction here. And that one's being opposed by friction force. The sum of all forces in the y still equals 0. So force normal, force gravity, force applied y. There's no motion up or down here, so that's why that still equals 0. So now we're going to plug things into our force net equation. So we'll have 35 times A is equal force applied x, which is 130, times the cosine of 20, minus friction force. And remember, friction force is always force normal, mu. So I'm going to say 387, which is our force normal, solved for above. And multiply that by a coefficient of friction of 0.30. So then the acceleration is 0.17 meters per second squared. So just one more thing to point out in this question again, and probably said this many times, is that friction force always force normal mu. The way you find force normal can change, and that's what's important to remember here, since our force normal was calculated a little differently. And again, we just place it in there. And this is how angle pull calculations are done.